Hi, let's do some more mental math together. This time I want to look at scientific notation, and I've done a couple of common things that you'll see in AP, possible multiple choice questions, a gas question, equilibrium, rate, and then another equilibrium right here. This is equilibrium for an ice table. This is equilibrium finding the equilibrium constant. So all of these, you could possibly see these as multiple choice questions. So I have two recommendations for you, actually three. First, change your numbers to whole numbers so that you can easily multiply and divide, and just adjust the scientific notation. Okay, that's the first trick. Make these numbers that your brain can comprehend and move through quickly. Here, remember with exponents that when you multiply bases, you add exponents, and if you divide the bases, you subtract the exponents. You'll see me do both of those today. I have 4 problems up here. Last thing that I wanted to remind you, last recommendation, know your basic fractions. This is going to be things like, let me put it up here. You know that 1/3 is 0.33. You know that 2/3 is 0.67. You know, 1/4, 0.25. 1/2, 0.5. You know, 3/4 is 0.75. I think it's also handy knowing that 1/8 is 0.125. You're going to know that 1/6 is about 0.16. You're also going to know that 1/7 is about 0.14. And it's good to know, of course, your tenths. You know that's just 0.1, and you're going to know the 1/5. Let's see. Yeah, I think that's good. Oh, of course, your 1/9 is going to be your 0.11. So those, just knowing those basic fractions, review those. If you need to review those, review those. All right, let's do some examples. So we're going to start with an ice table right here. We want to solve for this x squared, and I have a second video under basics on how to do mental math with square roots and cube roots. So watch that video if you need help with that. Okay, here's what I will do. I am going to make this 5 times 10 to the minus 3, because 5 is a godly number that I can deal with. 0.005, that's just too much for my brain to have to comprehend. So I'm going to multiply this by 5 times 10 to the minus 3. Oh, that is so much easier. What's 5 times 4.1? Well, 5 times 4 is 20. If you want to get fancy, 5 times 0.1 is 0.5. Now, our exponents. I multiplied, so you add the exponents. So that's going to be minus 3 plus minus 8. It'll be x to the minus 11. And then clean it up just a little bit. We want to write scientific notation with a ones place. So this would be 2.05 times 10 to the minus 10. And that's the actual answer. That's the answer right here. That's going to equal x squared. Okay, that equals x squared. So there's an example. Move the decimal. You'll have to adjust the scientific notation to get numbers that are easy for you to do mental math, to multiply and divide. Okay, let's do this pressure one. This is a good one for pressure. I have a trick for you, and I've totally seen AP use this trick. If students know it, it makes their mental math so much easier, where they rig it to get really clean numbers if you know this trick. 0.0821 times 298 is 22.4 liters. That's what we have at STP. 1 mole of any gas fills a volume of 22.4 liters. So have that memorized. Those two numbers multiplied is 22.4. AP, I've seen them do this a lot on multiple choice. They'll give students 25 degrees C, and then you have to find, you know, either moles, pressure, or volume. But if you know that's 22.4 right there, oh man, it makes that problem so much easier. So you don't have to deal with the 0.8 times 10 to the minus 2 and that 298. Okay, so memorize that. Now, doing this, here's how I would start. I like multiplication better. So I would take this 7 and make it 7 times 10 to the minus 2. I can deal with 7 a lot easier in my head than 0.07 times 22.4. Okay, so 7 times 22, that's pretty easy. Break it out. 7 times 20 is 140. 7 times 2 is 14. So 140 plus 14 is going to give me 154. okay, 154. Now the 0.4, if you want to do that, you can. 7 times the 0.4, that's going to be, 7 times 4 is 28, but since it was 0.4, it'd be 2.8. If not, just ignore it, okay? If that's too much, just ignore it, it's fine. Or you can go, oh, it's a 0.4, it might add another, one more, it might add like a 5 if you want. Doesn't matter. I'm going to go ahead and leave it as the 154, where I just multiplied 7 times the 22. Now, I have to take care of the scientific notation. This is understood to have 10 to the 0, okay? There's no scientific notation, so this is still just going to be times 10 to the minus 2. Now, I've got to divide it by this. So 0.25, the fractions, the decimals, they're kind of hard for me. So I'm looking at this saying, all right, what can I change this to that would be easy for me to do? So 0.25 is kind of hard for my head. So then I say, well, what about 2.5? No, it's still hard. What about if I move the decimal twice, 25? Like, yeah, that totally works. I can divide that. So 25 times 10 to the minus 2. So notice I move the decimal 2 to the right, 10 to the minus 2. And then this, if we round, 150 divided by 25. How many quarters fit in $1.50? 6. There you have it. There is your 6. And then remember exponents, if you are dividing bases, you subtract. This would be minus 2 times 10 to the 0, which is just 1. So my answer, my guess, would be really, really close to 6. The actual answer on that, let me find it for you. It is 6.85. So pretty darn close. I mean, for multiple choice, the answers that they give you, they wouldn't have anything that would be closer than that. It'd be obvious that it was 6. Okay, so there you have one for the ideal gas law. Let's come and look at rate. Let's say that you have the equilibrium constant and you have 2 concentrations. This would be a second order reaction. And we've got to multiply this to find the rate. Okay, so again, decimals I think are a little bit hard. Let's change it. Let's change it to a whole number. So this would be 5 times 10 to the minus 1 times 5 times 10 to the minus 1. Notice how I do this in steps. I don't try and do everything in my head at once. I'll do it one at a time. So 5 times 5 is 25. I add exponents times 10 to the minus 2. Okay, 25 is much easier for my brain to deal with. Now we're going to multiply this by 4.3 times 10 to the minus 3. Oh, 4 times 25, 4 quarters, it's going to be 100, equals 100. Now I have to add the exponents. So I've got my 10 by 10 minus 3 plus a minus 2 times 10 to the minus 5. Now if I want to clean this up, put the scientific notation back to a ones place, move the decimal 2 places, 1 times 10 to the minus 3. And the actual value on this is 1.075 times 10 to the minus 3. So it gets us pretty darn close, pretty close right there. Okay, this is an ugly equilibrium expression. This is going to be finding, if we're given at equilibrium, all the concentrations, what is the K value? What is the equilibrium constant? And kind of a mess, Where I would begin, I would just start with multiplication because that's easiest for me. I would take this as 6.25 is squared times 6.25. Okay, I'm going to multiply that. Well, 6 is easy. I'm going to do 36 right there. Okay, and the 0.25, no, it's too much for me to think right now. Okay, I've got 90 seconds on this question. I'm not going to spend more time on the mental math. So I've got 36 now. Okay, took care of this part right there. Times 0.125. Okay, times 0.125. So where to go from this? What's going to be something easy in my brain? See, I look at that 0.125 and I'm like, okay, that's an eighth. What's an eighth of 36? You could do that. Or I like this, 1.25 times 10 to the minus 1. How come? 1 times 36 is easy. I like that. So 1 times 36, notice it's 36, but I do have that 0.25. Now that's an easy fraction that I have memorized, a fourth. Well, how many times does 4 go into 36? 9 times. So if I multiply this, it will be the 1 times the 36 and the 0.25 times the 36. 0.25 times 36 is 9. So 36 plus 9, that's going to give me, I'll put it over here, 45 times 10 to the minus 1. Okay, so notice it was 36 times 10 to the nothing, 10 to the 0, times, I changed this to 1.25. 1 times 36 is 36. 0.25 times 36 is 9. 36 plus 9 is 45. All right, now, what I would do down here, I'm going to take that 1 and go 1 times 10 to the minus 1. I'm going to have 3 of those, times 1 times 10 to the minus 1, times 1 times 10 to the minus 1. Well, it's going to give me 1 times 1 times 1 is 1, times 10 to the minus 3, okay? Because sometimes with decimals, I'm like, well, how many zeros are there if I'm just multiplying decimals? Some people are really good at it, I'm not. So I've got to write down that scientific notation. Now, let's multiply that by 2 times 10 to the minus 1. Okay, easy. 1 times 2 is 2, and minus 3 plus a minus 1 is going to give us 2 times 10 to the minus 4, right there. Okay, good. So these numbers, so much easier to deal with because I'm dealing it with a tens and a ones place. So 45 divided by 2 is going to give us what? 22.5. And now I'm going to subtract. So this is going to be a minus 1 minus a minus 4. So that's going to be times 10 to the what? Positive 3. 10 to the positive 3. Let's make sure that I did everything. Minus 1, 3, yep. Minus 1, great. And then here, yep, we all look good. Okay, nice. So we end up with, when I divide this, 25 times 10 to the minus 1 divided by 2 times 10 to the minus 4. Divide just this part, 22.5 times 10 to the 3. Let's see here, and I don't know if I did this one. Let's see. I don't think I calculated that one out in my calculator, but we could even, it is going to be pretty darn close right there. That would be pretty close. Okay, so there you have it. We're going to have mental math scientific notation. If you want to stop the video, you can. I'm going to go ahead and calculate this really quick because I want to make sure that I did that correctly. So 0.625 squared. And, oh, do you know what? I see an error that I made. I'm so sorry, you guys. Look right here. I changed this. Darn it. So sorry. This was times 10 to the minus 1. I'm so sorry. Times 10 to the minus 1. So this is actually, add this times 10 to the minus 2. So when we add those two together, multiply, add those two together. So sorry. It's actually a minus 3 right there. Oh, it's a good thing I put that in my calculator. So this would be minus 3 minus a minus 4 is going to give us a plus 1. Let me change that, plus 1. So the answer 225. Let's finish it in the calculator really quick. Just make sure there were no other. Sorry, that's why you always have to calculate it before you do it. Parenthesis. Oh, yep. The actual answer was 244. Nice. So really close. That's the actual, and that was our not our guess, our estimate. It was our estimate. Okay. So sorry, I moved that decimal and forgot to put times 10 to the minus 1. All right. So big numbers. Learn from my mistake. Be really careful. Write it all out. Don't do it too quick. Actually write it out and make sure that you include that scientific notation. Okay, so the key, it is going to be change to numbers that your brain can handle, whatever's good for you, and just manipulate the scientific notation, knowing that when you multiply, add the exponents, when you divide, subtract the exponents, and you'll be really close, really close. Okay, good work. Thank you.